Okay, let's start with a situation you could easily find yourself in. You're asking the user for a number, and you give them a command here, enter an integer, and then maybe you go ahead and convert their number to an integer, which makes sense, right? If you don't convert it to an integer, actually, you know what? Let me put this as number 2, and we'll try to run this code here. Okay, so it says enter an integer, and if they would put something like 2, whoops, 2, it's going to give a error here, a value error. Notice that it says a value error. Before, we haven't really cared too much about the type of error, but now as we get into try except, we're going to be able to handle the specific errors, so it's helpful to know what kind of error it is. So that was a value error. So what we can do here is we can package this. I'm going to go to indent region here, and I'm going to go out to the left margin here and do a try. And then out here do except, so here I'm putting, notice I'm putting this specific type of error, and then I might say something like print okay, so this way, instead of, this is what's going to happen. It's going to go into here. It's going to ask them to input an integer. And when it does, it'll save it as this variable, which it did fine before. That was not the problem. The problem then came in this line when it tried to convert those letters into an integer. And Python doesn't know that TWO represents the numeral 2. So this caused a value error. So what's going to happen is think of it as like your plan A. And if something goes wrong in your plan A, you jump to your plan B, which is your except. If everything goes smoothly through your plan A, your code will never even touch your except. Your except is only activated if something happens in the plan A. And then it goes down and says the specific type of error that it ran into, it'll check down here for an except statement. And in this case, when it gets that value error, it'll say, oh, okay, we have a plan B, and that is to print this. And so let's run that and show you what happens. So it says enter an integer, we'll do TWO, and then instead of crashing and giving the red letters like before, now it goes down to that except statement and does what we tell it to do if it ran into a value error, which we did. Now you might say, well, it's not very helpful because it still doesn't let the user input anything or continue with the code. Yeah, you don't see the red letters, but it doesn't let them continue. And that's exactly right. So that's why we need this entire thing, or one way to do this is to package this entire thing inside a while loop. So we could let me show you how it would work like this. While true, so if you haven't watched the video on while loops yet, make sure you watch that first because I'm making the assumption that you've seen these before. So while true, true will always be true. It's a Boolean, but it's kind of a trivial Boolean because it's always going to be true. So this is going to run enter an integer. Well, if I enter an integer 2, notice like my plan A is working just fine here. Here I'm going to dip into my plan B, and it's going to say, give me some instructions on how I should enter it. But even after I enter it then, it's still going over. So this is helpful. Now after I have the message, I still get another chance to enter, but it's still caught in a loop. So I somehow need to break this loop. Now there's a couple different ways I could do that. One way would be to break it right here, and that way, if I make it through my plan A entirely, well, that tells me that either, that tells me, sorry, that number 2 is in integer form. The only way I will ever make it to this ending of the plan A is if I've successfully completed this step. If this sends me to the accept, it'll print this, go back up here, and I'll be caught in this loop until I successfully enter an integer. At that point, it'll break, and I can say something like, outside of the while loop, I can say something like print number 2 is a valid integer. Okay, so I'm going to run that, and maybe I try 3, 2, I'm getting several chances, and then I go ahead and enter an integer. That'll take me out of that entire try except and put me down here. So this is one way here to make sure that I have a valid integer. But value errors aren't the only type of errors that could happen. Let's say that we have, let's see, how would we do this? I'm intentionally trying to force a different error. Okay, let's say we have this, and maybe we don't have this here. Okay, so I have my accept here to catch any value errors, but when I run this, if I try to enter an integer like, I don't know, just say 3, I get not a value error. If I had had a value error, we would not have seen these red letters. We would have seen this comment here, even though that comment wasn't really applicable to our situation. That's what we would have seen if we had had a type error, because our code has an exception for the type error, or sorry, the value error. We don't have anything for the type error. So first of all, what's the error? Well, in this case, the code, I never converted number to an integer. So right now, the number itself is still a string. And when I try to add a string to an integer, that creates a type error. So what I could do then is also do accept type error. And maybe I print, oops, that's a problem in the coding, something like this. So now if I go here and I type in an actual, well, maybe I type in, let me do the, oh yeah, because I've deactivated the other line here, this line right here. Okay, so let's say this is now a valid integer. Yeah, okay. So I'm trying to force both of these errors at once, and it gets a little sticky. But I think you get the point that if the code in plan A runs into any error, no matter what the error is, it's going to go down and check the exceptions. If there is an exception for that particular type of error, it will do whatever I tell it to do. I can tell it to do a for loop here, blah, blah, blah. Whatever I tell it to do, this exception doesn't have to be one line. This exception could be like a big block of code. That's fine. So the other thing I can do is, if I don't know what type of error it's going to be, or if I really just want to be safe, I can say just accept. Like maybe you've done a Google search and say it says something like, "Oops, this is embarrassing," or "error blah blah blah, file not found." This at least, instead of the red lines, it gives them some kind of information here. So let's delete this line here. Okay, and let me take these errors out so you can see what happens if it catches any error here. So enter an integer, I go 2, I couldn't find your error, sorry. Even though this was this would have been a value error, because I only had the exception as accept, it gives them this message, and then it sends them back, because I'm in that while loop, it sends them back to this try right here. And it's going to continue to do that until we make it to the break statement, in which case we would get out of the loop. So what's best? It's best if you know a specific type of error that your user's potentially going to run into. So another one is when you're accessing files. File not found error is a really important one because it's very possible they mistyped the name and you could have them try to type the name again. It's also very possible they're in the wrong location, that the file's not in the location that the Python file is in. So if you're ever going to have them access a file, then you should have file not found. If you're doing something fancy like emailing them, which runs into problems very frequently, you should definitely have some kind of try and accept. The goal here is to avoid the red letters at all costs. You don't want the user to see those red letters. And then second, ideally you want the program to continue to function if at all possible. But still, above getting the red letters would be, okay, maybe your program stops working or it runs into a brick wall, but you at least have a printout somewhat explaining a situation to the user instead of the red letters. You want to avoid the red letters at all costs, and the more specific and the more sustainable for the code you can do, the better. But make sure you have some kind of accept in there. And if you're going to be giving the user multiple tries, then you should have some kind of while loop. You could either do a while true with a break once it completes plan A, or you could have some kind of user choice in here, and it might be something like, well, user not equals Q, and maybe above here we have something like user equals A. So this will run the while loop as long as the value of user is not equal to Q. So it'll start, initially the user value is A, so it would enter the try loop, and then at some point maybe you give, let's say user maybe enter Q for quit. And this way, when you get to this point in the program, if the user would type a Q, then it'll go up here again to the while loop, but now user actually does equal Q, so it won't enter the while loop anymore, and it'll jump past the entire while loop. I'm not sure in this particular case where you're just trying to get a valid input, it's probably easier to have a while true. But when you're asking them to play again or something like that, then certainly you want them to have, you want the while loop to be based on whatever their input is. That way they can keep playing until they give a certain input like Q for quit, and then that'll end the while loop. Okay, so that's the basic idea of try and accept. Again, Google is your friend on this.